What is it? Is that the correct area?
Oh, no.
I think so, right?
Yeah.
Okay. How are we feeling with this, you guys? Again, that's the goal of these types of problems. You want to somehow minimize or maximize something. And I like that first problem, that number 1. It's actually on a closed interval. And number 1 with the whole, whatever. So actually the point that you solved for is actually the minimum. The endpoints was the maximum, which was kind of interesting. In this case, there is no, what's the domain of this function? Of this area function? X can't be negative, though. 0 to 1. Am I including 0 or 1?
No.
No, because at 0, we don't have a rectangle. At 1, we don't have a height. So it's everything, you can make a rectangle, everything between 0 and 1. And 0.5 definitely fits that case. How are we feeling with that, Sandy? So that's the goal, but that's why we're doing these types of problems. Because, again, if you wanted to graph it on your calculator, did anyone graph it? Let's just take a look at it. So graph our area equation. Area equals 2x times negative x plus 1. Hey, look at that little guy. So this is a window 0 to 3. So I'm graphing the area equation for number 5 in section 4.4. And we're looking at a window from 0 to 3, 0 to 3. And if I just calculate the max, I can calculate maximum. I go to the left, I go to the right, I guess. And there you go. With a little rounding, if you move to an x value of 0.5, you have an area of 0.5. Again, something we can do now with technology with our calculators. But something that may pop up without a calculator on the test. Okay? How are we feeling with that, team? Yeah? Let's do the boat problem. 20. Yeah.
In the answer that said it was like 0.87 or something?
This one?
Yeah.
Yeah.
Do you know if that was like from where she is now or from that endpoint?
It's from this distance. Oh, you look silly. That's a silly looking house. Okay, so what do we know about this boat problem? Does he look like... What do we know? So, the boat's 2 miles offshore, okay?
And that distance is 6.
This from here to here is 6 miles, okay?
She rose at 2 miles per hour.
So the boat goes 2 miles an hour.
And she walks 5.
That's what I'm talking, she's kicking it. And she walks. Doesn't make any sense, right?
She walks 5 miles.
Oh, thank you. So this is kind of a wacky, weird problem. It's like, well, what do? Well, if we say we walk faster than we boat, she's not a very good rower for some reason. But how do we figure out, let me ask you this, how can we figure out how long it'll take her just to roll directly into shore? How can I do that? Dirt. Who said it? Who said dirt? Dirt. What's dirt? Distance equals rate times time. Dirt, dirt. Anytime you see rates, times, distances, just write it. Dirt. Now if I want to solve for my time, what do I need to do? What's time equal to? Dirt. D over R. Okay? So let's say that I just want to go directly in. How long is that going to take me?
1 hour.
Yeah, I go 2 divided by 2. And that's going to equal 1 hour. And then how long is it going to take me to go all the way to walk straight at it? Yeah, and I take my distance, 6 miles, and I divide it by my rate, and I get 6 over 5 hours. Now what's all this added together? That's how long it'll take you to go directly down and then directly over. What is it? 2, yeah, 1 and then 2.2 hours. Great. So I did like the longest way possible. I go all the way down and then all the way across. It's going to take me 2.2 hours. What if I go the most direct route? Boop, 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 boop. What's that total distance? How'd you figure out the square root of 40 so mathematically, Sandy? Okay. 2 squared plus 6 squared equals this side squared. 36 plus 4 is 40, and that's going to be the square root of that. How long is it going to take me to go directly at it? You're just going to row it out. Row it out. Yeah. Time is going to equal. And give me an approximation on this. Okay. So that just took her forever. So, okay, so those are 2 different ways. But I don't know, is there any other way? What if I just chose some random distance? You know, because this is a super long way to go. You know what I'm saying? There's got to be something better than that. I just don't know what it is. Do you know what I'm saying? Well, what if I went... some distance x. So from here to here is x. So I'm going to call this is my 6 to the house. X. How can I figure out that boating distance? Yes. Yeah, this is x, this is 2. So this is going to be 2 squared plus x squared square root is 4 plus x squared. Okay? How long is it going to take him to boat that distance? Lauren. How long is it going to take him to boat this distance? If this is the distance and you have the rate. What is it? You're going to flip that because this is the distance divided by the rate will give you the time. Okay? How much left do they have to walk? Okay? How much time is that going to take, Eves? How much time is it going to take to walk the rest of the way? If this distance is 6 minus x. Yeah. Exactly what you just said. 6 minus x over 5. How do we feel about that setup? You guys? Again, from here, how would you solve for the minimum amount of time? What x value you should choose to minimize time? What should you do, Jesse? Take the derivative and set it equal to 0. Cool? Again, these are ways to solve these problems. Again, these are tricky. And the only way you can get better at them is to just practice. You've got to work after school in groups. You can't do these by yourself at home. It just doesn't work. Not these. It's like, how do you do this? How do you do this? Okay, you guys? All right, let's get some stuff back here.